Hey, very good morning, students. Let us look into the characteristic table and equation for SR flip-flop. When I say SR flip-flop or any flip-flop, you know flip-flop is a memory element used to store the data. The first type of flip-flop is SR flip-flop, which will have three inputs, clock, S and R. What is characteristic table? Characteristic table means we need to write what is the next state depending upon the previous state and inputs S and R. Okay. When Qn is previous, Q of n plus 1 is next. You should understand. Qn is previous, Q of n plus 1 is next. Okay. Now, since there are three inputs, give the combination 0, 0, 0, 0, 0, 1, 0, 1, 0 from 0, 0 to 1, 1. Fill this with the data. You know, three inputs, it means 0, 0, 0, 0, 1, 0, 1, 0 till 1, 1, 1. After filling it, what you need to do is SR. The simple way of remembering SR flip-flop is when S and R both are zeros, there will not be any change in the output. So whatever you have in Qn will come as such. So what is the syntax? When S and R are 0, 0, there will not be any change in the output. Whatever value you have in the Q will come in Q of n plus 1. When reset is 1, can you see? When R is 1, reset is 1, the circuit gets resetted. So output will be zeros. When reset is 1, whatever be the value of S or Qn, the output will be 0. The circuit will get reset. When set is 1, when S is 1, set is 1, the output will be 1. When set and reset both are 1, you will not get any valid output. So you call it as invalid output. So it is very clear. When both S and R are zeros, there will not be any change. You call it as no change. Whatever value you have in Qn will come as such. When R is 1, 1, when reset is 1, the outputs are resetted 0. When set is 1, output is set 1. When set and reset are 1 and 1, it is invalid. Now draw the K-map for it to get the equation. How will you draw the K-map? Three inputs, S, R, Qn. So S, R, Q. Now plot it. What is Q of n plus 1? 0, 0, 0 means S bar, R bar, Qn bar. S bar, R bar, Qn bar is 0. Next is S bar, R bar, Qn. S bar, R bar, Qn is what? 1. So first fill all the data. After filling all the data, now can you see the bottom half? I can group this bottom half. So this is my first group, a quad group. Next is your vertical part. I can group this. This is my second group. So my first group, what is common for this all four? This one, which is nothing but yes. So I will write this as yes. What is common for this? Common for this is R bar and Q. R bar and Q. So what is my equation for Q of n plus 1? S plus R bar Q. This is how you derive the equation from characteristic table. Let us see for D flip-flop. D flip-flop is called data flip-flop or direct flip-flop. Whatever input you give, that will come as the output. So first let us write the characteristic table. You know what is characteristic table. Write Q of n plus 1. What would be the state? Next state if input and present state is given. So input is D because the flip-flop is D flip-flop. Input is D, present state is Qn. So what would be the next state? So it is two inputs. So 0, 0, 0, 1, 1, 0 and 1, 1. So what is D flip-flop does is if input is 0, output is also 0. If input is 1, output is also 1. So we can directly write as output is nothing but input. Q of n plus 1 is nothing but D. Okay. Next one is JK flip-flop. JK flip-flop similar to SR flip-flop. When J and K are zeros, there will not be any change. Q of n plus 1 is same as that of Q of n. When K is 1, it means J is similar to S, K is similar to reset, R. So when K is 1, it means reset is 1. So reset the circuit. When J is 1, means it is set is 1. So set the circuit. Whereas in SR flip-flop, when J and K, when S and R both are 1s, it is invalid. Whereas in JK flip-flop, the output toggles. What is output toggles? If Qn is 0, Q of n plus 1 will be 1. If Qn is 1, Q of n plus 1 will be 0. I repeat, when J and K are 0, 0, there will not be any change. If J and K, if the K is 1, the circuit resets. If the J is 1, the circuit sets. If J and K both are 1s, the output toggles. What is toggling? If Qn is 0, Q of n plus 1 will be 1. Qn is 1, Q of n plus 1 will be 0. Now do the plotting part. Draw a 3-variable K map, J and K, Q. So draw the 3-variable map. Put all these values in the maps. First, J bar, K bar, Qn bar is 0. J bar, K bar, Qn bar is 0. J bar, K bar, Qn is 1. J bar, K bar, Qn is 1. J bar, K, Qn bar. J, K, Qn bar is 0. So similarly plot everything. Now see where I can group it. I can group this one and this one. This is when I roll it, it becomes a pair. I can group these two. If I group this, can you see vertically, horizontally both belong to what? J. So I have written J. Vertically if you see, it is K bar, Q bar. Here it is K, Q bar. So Q bar is common. So I have written Q bar. Now see this vertical grouping. Both belong to what? K bar, Q. So K bar, Q. Now JQ bar plus K bar Q is the equation for Q of n plus 1. Over we are done with JK. Now final thing is T flip-flop. You know T means toggle. What is the characteristic table? I need to write what is Q of n plus 1 depending upon my state Qn and T. Since there are two inputs 0, 0, 0, 1, 1, 0, 1, 1. I said if T toggle flip-flop, it means when T is 0, no change. Can you see? When T is 0, no change. Qn will come as such to Q of n plus 1. But when T is 1, it toggles. It means 0 becomes 1 and 1 becomes 0. I repeat, when T is 0, there is no change. What is no change? Whatever value you have in Qn, that comes as such to Q of n plus 1. Whereas when T is 1, the output toggles. Qn is 0, Qn plus 1 will be 1, Qn is 1, Qn plus 1 will be 0. Now draw the characteristic table. It's a K map. Now see what are the inputs? T and Qn. So T and Qn. Now draw it. So what are the two inputs you have? T bar, Q. T bar, Q. Write that one. T, Q bar. T, Q bar. Write that one. You cannot group it. So individual groups, it is T, Q bar plus T bar, Q. So this is your output for characteristic equation for T flip-flop. This is how we could easily identify or write the characteristic equation for all the 4 flip-flops. Thank you.